In this very lesson, we shall be looking at logarithmic equation leading to a simultaneous equation. Logarithmic equation can be transformed into a simultaneous equation when properly manipulated. So we have some few examples. Let's go through them to see how we can approach questions of this nature. So we want to solve these two equations simultaneously. In other words, we want to find the value for x and y that satisfy these two logarithmic equations. So we have log to the base of 10, log to the base of 10. Since these two logarithms are equal and they are assuming the same base, we can equate their arguments or the numbers. So with this, we shall have 5x minus y is equal to what? 9. Now let's look at this one also. We have log to the base of 10 is equal to log to the base of 10. Since these two logarithms are equal and assuming the same base 10 and 10, we can equate their arguments. So we shall have 3x plus 2y is equal to 8. So let's rewrite it. We have 3x plus 2y is equal to 8. Let's call this equation 1. And then let's call this equation 2. Now we have two linear equations and we can solve them simultaneously. So in doing that, we can use any of the methods that is used in solving a simultaneous question. We can use the elimination, the substitution, the graphical method. We can also use the Cramer's rule. And lastly, we can use the calculator. So let's use the eliminator method. So we can do that by multiplying equation 1 by 2. So we are going to multiply equation 1 by 2. So 2 times 5x will give us 10x. We have minus 2y. And then we have 18. So let's call this equation 3. Now let's add equation 2 together. So we have add equation 2 and equation 3 together. So we have 3x plus 2y. And then equation 3 we have 10x minus 2y is equal to 18. So when we add them together, we are going to have 13x, this will give us 0, is equal to what? 26. So we want to look for the value for x. So let's divide both sides by 13. So we have 13x is equal to 26. This and that will cancel. This and that we have 2. So we have our x is equal to 2. Now let's look for the value for y. So let's substitute s is equal to 2 into equation 2. So we are substituting the value for s into equation 2. Equation 2 we have our x is equal to 2. So we have 3 is equal to 8. 3 times 2 give us what? 6. And then we have plus 2y is equal to 8. We are looking for the value for y. So what do? Let's bring 6 to the other side. So we have 2y is equal to 2. So you can say our y is equal to 1. So the value for x that satisfies the equation is 2. And then the value for y that satisfies the equation is 1. As easy as that. Let's look at another example. So we want to solve these two equations simultaneously. In other words, we want to find the value for x and y that satisfy these two equations. So we have x multiplying y giving us 80, and then we have another logarithmic equation, log of x to the base of 10 minus 2 multiplied log of y to the base of 10 giving us 1. Now looking at these well parts, we can apply the power law, and this is the power law where you have the logarithm of x to the power n. This power will come and multiply the logarithms. Similarly, if you have this number or the power multiplying the logarithms, we can write it in this very form. So with this aspect, we shall have log to the base of 10 of x, and then we have this will come to this well part. We have log to the base of 10 of y raised to the power 2, and this is equal to 1. Now looking at this, we have log to the base of 10, log to the base of 10, and then a minus sign. Log to the base of a, log to the base of a, and then a minus sign. So we can apply the division law for logarithm to write this in this very form. So we are going to write this in this very form. So we are going to pick one of the logarithms, and then we write it as x divided by y squared is equal to 1. Now once you have this, we can convert this into an exponential equation. The base of the logarithm will move and become the base of the power, which is 1. So you have 10 raised to the power 1, and then we have x all over y squared. Now let's do some cross multiplication. This will multiply this, this will multiply that. So we have our x is equal to 10y squared. So let's call this equation 2, and then let's call this equation 1. So we have x is equal to 10y squared. We are calling it equation 2. So we have equation 1 and then equation 2. Now we are saying that x is equal to 10 times y raised to the power 2. It means that x is the same as that. So we can substitute equation 2 into equation 1. So we have substitute. So we have 10y raised to the power 2, and then we have our y is equal to what? 80. Now this multiplying this will give us 10 times y raised to the power 3 is equal to 80. Let's divide both sides by 10. Both sides by 10. This and that will go. We have our y cube is equal to 8. We want to find the value for y, not y cube. So let's take the cube root on both sides of the equation. So we have our y is equal to cube root of what? 8. And this is going to give us y is equal to 2. Now that we have the value for y, we can find the value for x. So we are saying that x multiplied y will give us what? 80, and our y is equal to 2. So we can say that x multiplying y is equal to 80. So we have x, our y is 2. 2x is equal to 80. Let's divide both sides by 2. This and that will go. We have what? 40. So our x is equal to 40. So the value for x and y that satisfy these two logarithmic equations are x is equal to 40 and then y is equal to 2. As easy as that. Let's look at our last example. So we want to solve these two equations simultaneously to find the value for a and then b. Let's start with this well part. We are saying that 3 multiplying log of a to the base of 2 gives us b. Now we can apply the power law, and this is the power law. So we can write this as log to the base of 2 of a raised to the power 3 gives us b. And applying the power law to this, This is what we'll be coming out with. So let's call this equation 1, and then let's bring this particular equation log to the base of 2 of what? 4a, giving us b plus 4. Let's call this equation 2. Now once you have this, let's subtract equation 1 from equation 2. So we have equation 2 log of 4a to the base of 2 minus log to the base of 2 of a raised to the power 3, and then we have b plus 4 minus what? B. So from here you can see that this b can cancel this b. We have our log is equal to 4. So at this very part, you can see that we have log to the base of 2, log to the base of 2, we have a minus sign. So we can apply the division law for logarithm. So we are going to write the whole of this in this very form. We are going to write the whole of this in this very form. So what are we going to do? We are just going to pick one of the logarithms, log to the base of 2, and then we have 4a all over what? A raised to the power 3, giving us what? 4. Now once we have this, we can convert this into an exponential equation. So from here we have 2 raised to the power 4 is equal to 4a all over what? A raised to the power 3. Now this 4a all over a raised to the power 3 can be written as a times a times a. So this a will cancel this a, we are left with 4 all over a raised to the power 2. So we can simplify this and write it as 4 all over a raised to the power 2. Now from here we can do some cross multiplication. This will multiply this will multiply that. So we shall have 2 raised to the power 4 give us 16, a raised to the power 2 is equal to 4. Let's divide both sides by 16, both sides by 16, this and that will go. We have our a squared is equal to what? 1 all over 4. Now our interest is to find the value for a, not a squared. So let's take the square root on both sides of the equation. So we have our a is equal to plus or minus 1 over 2. And since the logarithm of a negative number doesn't exist, we will go for our a is equal to the positive half. Now that we know the value for a, we can find the value for b. So let's substitute it into equation 2. So we have log of 4a to the base of 2 is equal to b plus what? 4. Our a is what? Half. So we have log of 4 multiplying 1 over 2 to the base of 2 is equal to b plus 4. So we shall have log of 2 to the base of 2 is equal to b plus 4. Now applying this very property, the logarithm of a number to the base of the same number gives us 1. The whole of this is going to give us 1. So we have our 1 is equal to b plus 4. We are looking for b, so we can say that our b is equal to negative 3. So the value for a is 1 over 2, and then the value for b is what? Negative 3. This brings us to the end of today's lesson, but I'm going to give you one tutorial set question. Try your hands on it. So this is your tutorial set question. See you tomorrow. Bye bye.